Hello guys, welcome back to me, and today I will show you how to do the analysis for two different material, which one is the composite material and the other one is the isotopic material, like aluminum or steel or structural steel or anything else. Just have the isotopic. So first of all, I we should to design our geometry first. We do the basic one, the simple one, the sandwich. You know, yes. Okay. Uh, Now we should design our geometry first. Because we do the basic one. Just put the square here and put dimension here. Let's see. Okay. And then after that, we define our thickness for the geometry here. We got a specimen. We design our specimen here. Yes, specimen into the 1 millimeter. No, I need to take, okay, 1 millimeter here, and we define the surface geometry here. Uh, One for the bottom, for the lower part, and one for the upper part. So we have the upper part and the lower part for the object. Then we close this window and duplicate our geometry here into the two section, one and two. So this is will be the composite geometry, and this is for isotropic geometry. So we got two geometry here. We will do the composite first. Drag the ACP here. Okay, we did it again because the composite just need the surface of the geometry. So we should remove the other one, the solid and the surface which the upper part of surface. So we just use the lower part of the surface of the geometry and go combine it into the ACP. Okay, because we just need the down solid and the upper part of surface. Oops. Solid and surface. Okay, we do it because we just need this one, the lower part of the geometry. You have to red plus again, and then drag the geometry into the ACP. Don't forget to define our engineering data. For the example, we will use the epoxy. Yeah, okay. This one. Oh no. This with the simple one, the basic epoxy carbon UD. Okay, we add it and going to the project. Do the modeling. We define the mesh for our composite material. And the thick we in this model we should define our thickness and the material, but it's not will affect the analysis because it will be reset again in the setup of the ACP. So don't worry, just put the random number and the random material. It will not give the effect of the analysis because once again it will be reset in the setup. Okay, and it's take a long time. Be patient. Okay. Okay, here. Okay, this thickness is will not be giving the effect, but okay, okay. Just put the structural steel and go to the mesh. Update. And then we got our mesh in here. Okay. Mm, this we put the top. Okay, so it will be no problem. Okay. it's not really given. It will be reset again in the ACP. Okay, put on the model here, going to update. Let's take a look. Let's take a look. Check in. Okay, down for the metal, go to setup, go to edit, we did the processing here, we got the processing here. Okay, got the our setup here with the material data like as usual, create fabric, go to the material we choose, epoxy carbon. Don't forget to define your units first. Okay, I will use the millimeter. Go again to the fabric, edit again, properties. Let's just put it 0.5 millimeter. Apply. Okay, and our fabric. Let's take up the minute because it's not complicated. Okay, going to the rosette here, create rosette. Okay, choose the parallel because this is square. Choose the origin. Okay, define the origin. Let's put where's my okay, there's the axis. Okay, let's put the Z into okay, there we go. We got the XYZ here. Press OK. Okay, so this will be the 0, the 45, and the 90 degree. But no worries, not it's not in here. Going to the correct oriented section, or we call it OSS. Put the element set. The point here. Let's put the same. Okay, here. Okay, this is the point. Oops. Okay, but the direction for the stack up is not going to downward. It should be the upward because we changed the global, but we should follow this axis here. It's just it's you define your design, your own design. So in this when you define the rosette or SS, you should follow your your illustration here. Okay, because this is my video, so I define my own. The rosette, we choose the rosette as usual. Okay, going apply. Okay, we got the our modeling group here because we want to define the thickness is 1 millimeter and our thickness of the composite is 0.5 millimeter. So we just need two fabric here. Okay, composite. So apply with the oriented selection and the material we use is fabric 1. The angle we will use for 90 degree. Okay, so it will be going here uh, linear to the z-axis in this axis, the local axis. Yeah, and put uh, again the OSS. Okay, here and the fabric 1 put into the 90 degree again. Okay, that we got our concept here. Just going to update this here. And let's see the thickness. Okay, the thickness here is so 1 millimeter. The angle, we don't get it. It's going to the 90 degree for the angle. Just like as usual to find the composite. If you still don't know how to design the composite, you can just watch my other video because I will not tell you again how to design how to design the composite. Okay, after that we done for the composite, so we're going to design the our isotropic material. So we will use the mechanical model. Oh, there we go. Into the mechanical model. Going drag the geometry, put into the mechanical model. So we define again for the model. And this one, we should uh, define our geometry, and it will not reset like the ACP. So you need to really define your geometry here. The thickness, because oh, I'm sorry, we need to design our geometry first. Okay, okay, okay. We should define our geometry first, because we just need we don't need the solid, because we will define our solid with start using the surface, because the surface in the lower part is for the composite we divided. So we just use the surface in the upper part. Okay, okay, after that close the window and going to the model, define our mass, our thickness, our material we will use. In this one we should define our all this design we determine. Okay, okay, we got our object here, our material for the isotropic. It's just surface, so we need to define our thickness. Let's define it into the 0.5 millimeter. And offset type, we choose the into bottom. So get going to mesh here. So if you still don't know what is the offset type, so if you put it into the middle, so the surface it will be the middle of uh, the geometry. So let's just try it. Okay, when we choose the middle, the surface it will be in the middle of the our geometry. So because we want the thickness will going up, so we put the offset type into the bottom, or it will be going to the up. It will be start going up for the thickness. Okay, so that we don't all the material, the thickness, the mesh here. So we just can close the window, and right now we can do the analysis. So we do the analysis about the structure, break the setup, because I assume it will be the thin object. So we choose for the cell analysis and for the model here, going update the model. Okay, the model. Okay, after we done, going to the model and static structure, and this is will be defined. We will define our boundary condition and the analysis, like the support, the load, the contact region we will define, and analysis we want. Okay, so we got here our two different surface, the surface for the composite and the surface for the isotropic material. Okay, so we got two different objects here. Okay, first of all, we define our contact region, the connection or the contact region for these two different material. Because we do the basics, so let's just assume it will be bond. Okay, let's just assume the between for the composite and the isotropic is will be glue. the strong glue we will use. Okay, the contact will be the composite, and the target will be uh, the isotopic material, the steel material. Okay, that after we define our contact region, going to the structural here. Therefore, sorry, let's put it the force and the fixed support. With the fixed support. Okay, here I'm again fixed support. Okay, let's put the force into the mechanical model. I mean the isotropic material, the steel, into 1 kilonewton. Okay, let's going to the press press the object here, going to downward. Okay, the force going to downward, and let's put the fixed support on the one. Let's change to the H here for the one for fixed support, and for the other fixed support going here. Okay, so we got fixed support in this, in the left and in the right side. Okay, let's and then let's we see the total deformation and the equivalent stress analysis. Choose this into the layer. Okay, and let's solve it. So if you want to look for the each layer of the composite, you should use the ACP post. That's for the analysis, for the detailed analysis for the composites. Okay, here we got our material, our analysis here. The total deformation, equivalent stress. Okay, so it will be going here that. Okay, let's put into the true scale. When is the real scale? Okay, so we got this for the real scale, the true scale. Okay, there we go. Okay, okay, there you go. For the two different material, steel and the composite material. Okay, you want to ask question, you can just comment down below, or you want to comment this video, you can just go into the to just put in into the comment sections. Maybe I will see it, and maybe I will do it to your question. Like this the request for our friend. He recommend me to build the to make video for the analysis two different material, which steel with the isotopic material like steel or aluminum oil for the composite. So for the advance, uh, in the reality, it's for the application for the pressure vessel, or for the detail is a composite of a web pressure vessel type type 4. That's my thesis. I do the analysis for that composite, for that problem. So the composite, the tank, it have a linear and the composite material. So the linear, it will be the polyethylene or high density polyethylene, and the composite is the carbon fiber. So we have a linear and the composite, and we put the pressure in that and do the analysis. So that's for the advance, but because it will be take a long time, a really long time, and really complicated analysis, so we just do the basic here. Okay, okay, thank you guys, this viewers for watching. Don't forget to comment if you have a question on this side. Okay, maybe we will can give you the solution. Okay, see you next time, guys. Thank you.